Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 2, Lesson 1, Estimation. I like to think of estimation as being close but easy. Adults use this a lot when we are out shopping because shop owners are trying to trick us into thinking things are cheaper than they really are. For example, have you ever noticed when you're shopping that there are a lot of prices that end in the cents 99 or 98? Something that is $2.99 is actually a lot closer to $3 than $2, right? But there are a lot of people who don't feel strong about math, and so they don't want to do that rounding. They'll do something called front-end estimation, which we will also practice. That means just keeping the place of value that you want to use and changing everything else to zeros. Let's take a look at a number like that. Like 267. If I'm out shopping and something is $267, what a lot of shoppers do is they say, well, I'm not really caring about the $10 or the $1. I just care about how many hundreds of dollars this will be. So they'll just look at the number in the highest place of value. Front-end estimation tells us that we should estimate 267 as 200. Rounding is a little bit more specific than that. In rounding, we also use place value, but we consider the digits carefully and logically. We take the first half of the digits, 0, 1, 2, 3, 4, and say, if the number in this next place down from the one we want to keep is one of these lower digits, then we'll round it down to 200. But if the digit that is right below the digit we care about is between 5 and 9, we're going to say that that's going to be closer to rounding up, in this case to 300. So using rounding, I care about the hundreds place. The tens and the ones are too small for me to worry with for this problem. Is 6 right here lower than 5 or higher than 5? Well, it's a little higher than 5. 5 is our halfway point. And so in that case, I would want to round this up, 267 up to being closer to 300 than 200. And so rounding would be a little bit more precise there. In rounding, we would round up to 300. What if I wanted an estimation for the number 1,399? Well, if I'm doing front-end estimation, I'm just going to look at the highest place of value, the digit that's on the front, and say, meh, I don't want to be that specific. Let's estimate that to be 1,000, as you can see down here. But when we're rounding, we just want to get a little closer while still being easier. So let's imagine that I only care about the thousands place. I've got a 1 there. If I was going to change the other digits into zeros, then I would be at 1,000. If I am closer, however, than halfway, I'm going to round the thousands place up 1 digit to 2,000. So to do that, I'm going to look 1 place down from the place that I care about. In this case, it's the 3 in the hundreds place. Where does that 3 go? Well, here's the digit 3, and here's 3, and we can see when it's right here that the 3 is closer to 0 than it is to 9. So even if I'm just rounding, I will also round this to 1,000. Now, where you will be using estimation most of the time at school is in deciding if the answers to the problems you're working out are reasonable. I'll never forget, I had a student once, and we were talking about rich problems and how we could really wrestle with math for which there may not be one clear answer. And she got very worried. She said, Miss Foster, if nobody knows the answer, how will we know if we're right? One way to do that is to estimate to find out if our answers are reasonable. And reasonable simply means making sense. So let's find the difference here between 786 and 453 using rounding. Well, when I'm rounding, I know that I'm going to take all of my digits except the 7 in the hundreds place and change them into zeros. The question is, what will happen with the 7? Will I round down to just 700, Or is 86 close enough that I want to add another 100 to 7 and round up? In this case, the 8 is closer to 9, so we're going to round up. Like this. 786 rounded to the nearest hundred is 800. What about 453? I want to round it to the nearest hundred, so I know the tens and the single ones will be zeros. But I'm going to look at that tens place to help me. Now, anytime you've got a 5 there, it's extra difficult because 5 is right on the dividing line. But if it's 5 and above, we're going to round up again, which in this case would be 500. Now you have to do two things with this kind of problem. You need to do the actual subtraction and you need to subtract the rounded numbers. Well, 800 minus 500, that I can get pretty well. That is 300. Let's take a moment though to see how close we actually got. To help myself out here, I am using place value, and as we did, remembering addition and subtraction with regrouping, I'm going to start in the single ones place. 6 minus 3 is 3. 8 minus 5 is also 3, no regrouping so far, and 7 minus 4 is also 3. So the difference is 333. Is 333 close to 300, my estimation? Yes, it is. So I can tell that I've got a reasonable answer there. And that's one way we can check if we're likely to get the problem wrong or right. But what if we use that other strategy of front-end estimation to check the reasonableness of our answers? Well, in this case, when we're adding 6,572 to 8,144, if I just use front-end estimation, I'm just going to take all these digits I don't care about, the 572 here and the 144 here, and just change them into zeros right away. That sure does seem easier, doesn't it? It's less specific, it's less close, but it's quicker and easier. Now, adding 6,000 plus 8,000, I can just use my first grade math facts. 6 plus 8 equals 14. And I'm going to just type in those 3 zeros to say, dude, I'm adding thousands. But then I'm doing this estimation to see if my addition will be correct. So let's take a moment to do that this time. 2 plus 4, 6, no regrouping there. 7 plus 4 is 11. Ooh, I am going to do some regrouping. 110 and 100. 1 plus 5 plus 1 is 7, no regrouping from the hundreds place. And here we are. 6 plus 8 is 14. This 10,000 here is technically regrouped. So my front end estimate was 14,000. My actual answer was 14,716. So is my answer reasonable? I'm going to say yes, it's close. Could I have gotten closer? Maybe I could have by rounding. We just want you to be able to do either one. But we're also going to use rounding and front-end estimation to help us know if the answers to our multiplication questions or products are reasonable. Here's a really big multiplication problem, 242 times 4. Well, if I was to actually do that, I would say 4 times 2 is 8, and I know you did this in 3rd grade, so nod along with me if you remember. 4 times 4 tens would be 16 tens. Have to do some regrouping there. I'll leave the 6 tens there and the 100 up here. And then 4 times 2 is 8, plus that 100 we got from multiplying in the tens place, that would be 9 hundredths. So the answer is 968. But we're not done because we wonder, is this a reasonable answer? We're going to do some rounding. Now, for a lot of kids, they would think, oh, we'll round this number to its greatest place of value, which would be 200, because 4 is not closer to 9 than 5. And we'll round 4, so it's 1. If you have a one-digit number, you probably don't want to round it unless you're dealing with decimals. Then we'll do some rounding to the single ones place. But otherwise, we're not going to round this number because we still want to be close. 200 times 1 is wicked easy, but it's not really close enough. However, if I round 242 to 200, 200 times 4, well, let me see. 2 times 4 is 8. But these two zeros here say, dude, I'm multiplying hundreds, like those big yellow flats we have at school, or those green chips in our place value chips. And so we would add those two zeros as our secret math code that we've been multiplying hundreds. Is 800 close to 968? Pretty much. They're close enough that I think I'm correct here. But if I feel that it's kind of far, I might want to go back. Let's see. 4 times 2 is 8. That makes sense. 4 times 4 is 16. I put the 6 here, and I put that 100 up in the hundreds place. 4 times 2 is 8 again, plus 1 is 9. Maybe if it's not that close, I'll go back and double check. We've estimated with subtraction, addition, and multiplication. Now here we are at division where things get really, really tricky. Because, my friends, it's not enough to just round the number. Here I'm trying to find 92 divided by 2. So I could just use front-end estimation or rounding and change the 92 to a 90. 90 divided by 2. But here's my question. Can I divide 9 into two parts easily? Alas, no. 2 times nothing equals 9. So we're going to be using related multiplication facts, or I like to think of them as friendly facts, to help us estimate when we're checking to see if our quotient is reasonable. So let's look at some friendly multiplication facts. 2 times something will get me really close to 90, or to 9 in this case, because I'm thinking about these 9 tens here. Well, let's see, 2 times 3 equals 6. 2 times 4 gets me close to 9, that would be 8. 2 times 5 is 10. In division, we don't want to go over, because we only have this many things. So I might think to myself, a friendly fact here is that 2 times 4 would equal 8. Now the division fact that will help me is thinking that 8 divided by 2 equals 4. So this right here would be my quotient. Except when I was trying to get close to this 9, I was trying to get close to the 9 tens right there. So to really make this work, I've got to put a 0 after that 8 to make it 80, and a 0 after the 4 to make it 40. So I think that if I use the friendly fact 2 times 4 equals 8, and then I use place value to say that means that 80 divided by 2 equals 40, my quotient should be pretty close to 40 here. Of course, now I have to actually divide to make sure it's correct. And you did do this in 3rd grade last year. We started in the tens place, and we said 2 times something gets me close to 9. Wait a minute, it's 2 times 4. We just did that. In fact, when we estimate quotients, we're really just going to start with the first step of the estimation problem. 2 times 4 gets me close to 9 without going over. That would be 8. And we're in the tens place, so we're going to go ahead and put our 0 in there. Now maybe a parent is watching this with you and they say, oh, we didn't have to write the 0 when I was in school. Hi parents, trust me, we're going to put the 0 there. I'll explain it when we get to long division, but stick with me on this. We are going to put it there right now. Now I know it's going to take 4 tens, so if we were splitting it, with our 92 candies, you get 4 tens, I get 4 tens. That's 8 tens or 80 altogether. That leaves me with 2 in the single ones place, and 9 minus 8 is 1. To finish this, we would say 2 times something gets me to 12, and that would be 2 times 6. And 2 times 6 is 12, so because I'm having some space and time issues, I'm just going to squeeze that. It's 0. That means that our quotient is 46. Is it pretty close to 40? Yes. And so we can say that that quotient is reasonable. This, using friendly multiplication facts to find and estimate quotients, is wicked hard, my friends. If this felt difficult to you, maybe find your favorite multiplication or division fact game and brush up so you're ready for class. Hey, thanks for playing estimating and rounding with me, my friends. I have so much fun playing math with you. Bye-bye for now.